Hello friends, welcome to this exciting video on image formation by convex lens from your class 10 science light chapter. If you find ray diagrams confusing, don't worry. Today I will break down everything step by step with diagrams, explanations and easy tips. By the end of this video, you will understand how a convex lens forms images in different situations. So let's begin it. So let's learn what is a convex lens. A convex lens is a lens that is thicker in the middle, thinner at the edges. It is also called converging lens because it bends light rays inward towards a single point. Imagine sunlight passing through a magnification glass. The glass is convex lens. The rays meet at one spot and can even burn a paper. That's the power of convergence. Convex lenses are used in cameras, projectors, eyes, and even magnifying glasses. As you can see, they are even used in headlights of cars. In this chapter, we will learn how they form different images depending on where the object is placed. Before that, we need some key terms to know. So first key term is optic center. What is an optic center? It's a central point of lens. Rays pass through this point and go straight without bending. Our next term is principal axis. It's an imaginary straight line passing through the optic center and the center of both lens surfaces. Our next key point is focal point, or yeah, when parallel rays fall on the lens, they meet at the point after reflection is called focal point. Our radius of curvature 2f. This point is at twice the focal length. From this optic center, it helps us to decide the size and position of image. We will use all these points in the all ray diagrams. Before that, we need to learn some rules for drawing ray diagrams. So now let's begin. Let's learn the three golden rules to draw ray diagrams for convex lens. Our rule number one is a ray parallel to the principal axis passes through the focal point on the other side. A ray passing through the optic center goes straight without bending. A ray passing through the focal point comes out parallel to the principal axis after reflection. By using just these three rules, we can find out where the image will form. Now, let us apply these rules at different object positions. So, our case 1 is object at infinity. So, if an object is very far away, like a sun or a star, we say it as infinity. In this case, light rays coming from the object are nearly parallel. When these parallel rays pass through a convex lens, they meet at a focus on the other side. As you can see in the image is always formed real, inverted and highly diminished, almost like a small dot. That's why the sun looks like a small bright spot when passed through a magnifying glass. Let's go to our case 2, which is object beyond 2f. When an object is placed beyond 2f, here's what happens. The image is formed between f and 2f on the other side, means right hand side of the lens. It's real, inverted and it's smaller than the object. This is how a camera lens works. It forms a small real image on the film or a sensor. Use these rules. One ray parallel through F and one through O, straight. Yeah, now you can see. Let's go to our case number 3, object at 2f. Now, when the object is placed exactly at 2f, the image is also formed at 2f on the opposite side, means at right hand side. It is real inverted and of same size. It's very rare case but very important for ray diagram practice. Again and again, you should use the first and second ray rules to draw. Let's go to our next case, which is case number 4. When the object is between f and 2f. This case is interesting. If the object is between f and 2f, the image forms beyond the 2f on the right hand side or the other side. It's real, inverted and magnified, bigger than the object. The principle here is used in projectors, where the small slides are magnified on the screen, as you can see in the image. Let's go to our next case when the object is placed at correct f. When the object is at focal point or at f, the rays after reflection become parallel to each other. So the image is formed at infinity. It's real, inverted and highly enlarged. This is not a practical image to view, but very important to understand concept. Our last and final case, which is when the object between O and F. In this final case, the object is placed between the optic center and the focal point. The image is formed on the same side as the object. It's virtual, erect, and magnified. This is how magnifying glasses work. They make object appear larger and upright, means erect. As you can see in this image. Here is our small table, summary table. You can take this as a screenshot or you can write this in notebook. It's very much important for us. Understanding image formation helps not only in exams but also in real life applications. Cameras, telescopes, microscopes, projectors, and even in your own eyes. If you understand this topic, you can even solve numerical diagrams and write answers neatly in board exam. Thank you so much for watching. This video helped you to understand the concept clearly. Please like it and share it with your classmates. And if you want more science topics explained simply, don't forget to subscribe. Comment below if you want me to explain the concave lens next.